Hi everyone, welcome to Math Moment with Mr. Dustin. I'm Mr. Dustin. So today we're going to be discussing the quadratic formula. Now this is a concept generally taught in Algebra 1 in high school, which could be 9th or 10th grade depending on the curriculum. And so if you're older, this could be a great review, or if you're younger, it could be a great preview. There's also some pre-calculus in this. In the second half of the video, I derive the quadratic formula. So if you're just interested in how to use the quadratic formula, then I encourage you to watch the first half of the video. If you're interested in both or just how to derive the quadratic formula, then I encourage you to watch the second half of the video. Either way, it should be really fun. And so there's a formative assessment, and if you are interested in taking that, the link is in the description. And at the end of the formative assessment, there's a virtual visitor badge code that you can enter to earn that badge. So I encourage you to take the formative assessment to earn that code. So enjoy the video. All right, so today we'll be discussing the quadratic formula. Now this is a formula that is used to find the solutions to a quadratic function. In other words, the zeros or the x-intercepts, however you'd like to phrase it. So I'm gonna write an example of how you normally find solutions. This kind of goes off of the last video for Algebra 1, which was factoring. And so if we take one that is in factored form, we'll say x plus 4 and x minus 3. You can see this is in factored form. And so what we're going to do is we're going to set each factor equal to 0, right? So x plus 4 equals 0, and x minus 3 equals 0. And that's essentially saying, hey, when y equals 0, what is x? And so we can find that by solving for x. In this case, x equals -4, and x equals 3. These are two solutions to the quadratic function that is displayed at the top here. And so a quadratic function will have 0, 1, or 2 solutions. So what we're going to do is we're going to find a formula that will do all of this work for us. And you can take it directly from the expanded form. That's kind of the thing. It's kind of a bypass to factoring. So what I'm going to do is I'm going to tell you the formula in this first segment. And then we'll look at some examples of how to apply it. And then in the second segment, I'll actually derive the formula. And if you're curious to see how that actually works, then we can look at that, all right? So I'll erase this. The quadratic formula is -b plus or minus the square root of b squared minus 4ac over 2a. Now that's a lot of letters. I personally don't like letters as much as I like numbers. So let's figure out what all these mean. So I'm going to write the generic form of the expanded quadratic equation. So that'll be ax squared plus bx plus c, where a, b, and c are all just numbers, any number, and we'll see that later, all right? So this gets us x, and this we have to make sure is set equal to 0. And we set this equal to 0 because we're finding when y equals 0. Because in other words, this is like y equals ax squared plus bx plus c. So we went from this to this. And the how of that we'll go over in the second segment. So let's take a look at, oops, I'll leave the formula up. That's kind of the key to all of this. Let's take a look at some examples, all right? So we'll do at least 2 here. So the first example is 6x squared plus 11x minus 35 equals 0. Now, what are our a, b, and c? A, B, C. Just like that. So the A term goes with the x squared, B goes with the x, and then the C goes with the not x, essentially. So let's put all of these into our quadratic formula now. So -b. Now we notice we have a positive 11. We're going to have to make that negative to fit the -b. So -11 plus or minus the square root of b squared. So 11 squared minus 4 times a, which is 6, times c, which is negative 35. We'll extend that square root over 2 times a, which is 6. All right, so from here, I'm just going to kind of go over to this section of the whiteboard and then erase the parts that we figure out. But you'll see step by step kind of what I'm doing. And yeah, so this is equal to, now we know it's 11, or sorry, negative 11. That'll stay the same. Let's simplify what's in the square root here. So let's see, negative 4 times 6 times negative 35 is 840. Now, if you don't know that off the top of your head, that's fine. I actually used my calculator before this to figure that out. So it's okay to use your calculator here. 11 squared is 121. So inside the square root now, we have 121 plus 840. And then 2 times 6 is 12. Hopefully that makes sense so far. All right, let's simplify this a little more. 121 plus 840. Well, that gets us 961. So now we have negative 11 plus or minus the square root of 961 over 12. Now, what is the square root of 961? Again, I used my calculator, but the square root of 961 is actually 31. So now this is what we have. All of this kind of simplified to here. So what we're going to do now is we're going to kind of test two scenarios. The test scenarios are the plus and the minus. Notice how it's not just one of them, there are two of them. So we'll do negative 11 plus 31 over 12 and negative 11 minus 31 over 12. That's kind of how you solve this part of it. And once we get that, those are our two solutions. So negative 11 plus 31 over 12 equals 5/3. And then negative 11 minus 31 over 12 equals negative 7 over 2. And now these, I'm going to circle them, are our values for x. Those are our solutions. And so that's what we're trying to find using the quadratic formula. And had we factored this and done what we know how to do, you would have gotten the same thing, maybe the decimal version of them, but that's all there really is to it. So I'm going to show you one more example, and then we'll go into the break. So let me erase all of this here. We'll do 2x squared minus 4x minus 2 equals 0. Now, what are our a, b, and c terms? Well, a, b, and c. 2, negative 4, and negative 2. Now, let's put them into the formula. So, negative b, well, a negative negative makes a positive, so that's what we have to be careful about. So, we'll do 4 plus or minus the square root of negative 4 squared minus 4 times a, which is 2, and then c, which is negative 2, over 2 times a, which is 2. Now, let's simplify this. So what is negative 4 squared? Well, that's 16, and a positive 16 at that. And now, negative 4 times 2 times negative 2, well, that gets us 16, believe it or not. So 16 plus 16 over 2 times 2, which is 4. Now, let's simplify this part of it. So what's 16 plus 16? Well, that is 32. And now what's remaining is 4 plus or minus the square root of 32 over 4. Now, if you try it in your calculator, 32 is not a perfect square, meaning the square root of 32 is not a whole number, like 1, 2, 3, 4, etc. So for me, this answer right here would be sufficient. There are ways you can simplify it more, but I don't really want to get into that. The important thing is how to apply this into the quadratic formula and get it down to at least this form here. If you can go farther, that's great. If not, then this is okay for me. I mean, you'll have to check with your actual teacher to figure out, you know, what is good for that particular class. But this is as far as I'm going to go with this. But just know there are two solutions embedded in this. You have 4 plus the square root of 32 over 4, or you have 4 minus the square root of 32 over 4. So that's the important thing to remember. And so hopefully this makes some sense. The formative assessment is only on what we covered in this first segment. I'm not going to like put, you know, how to derive it on the formative assessment. I don't think that's entirely fair. So yeah, it'll just be on identifying which is A, which is B, and which is C. And then it'll be on actually solving something using the quadratic formula. And you won't have anything like this. It'll be more like the first example. So yeah, that is the end of the first segment. And we'll be going into our break now. Hi everyone, welcome back. I hope you enjoyed the break. So now we're going to be discussing how to actually find the quadratic formula. This is something you probably won't ever actually have to do, which is why it's not really on the formative assessment. But I figured for those of you who are curious about how it actually works, then this is kind of good for you. So here's what I'm going to do. I'm going to begin by trying to get x by itself. That's the goal. We want to have x equals a bunch of stuff. And ideally, that'll be what our quadratic formula actually is. So the first thing I'm going to do is I'm going to divide A like that. And so this is kind of like dividing each side by A, if that makes sense. So what's left is x squared plus b over ax plus c over a equals 0. And now what I'll do is I'm going to move c over to the other side of the equation. So you can do that by subtracting or c over a from both sides of the equation. So x squared plus b over ax plus equals negative c over a. So fairly straightforward so far. Now here's a part that won't make as much sense right now, simply because it's a more advanced concept. It's called completing the square. And what it does is it kind of makes this quadratic part of it into, like, the factored form is the same thing. So it's like x plus something, and then outside the parentheses squared. You'll see what I mean. So I'm just going to kind of give you that for now. I don't really want to teach you completing the square in this video, maybe in a future video. But it's a process called completing the square that gets you to the next step. So that'll bring us to x squared plus b over ax plus b over 2a squared. Oops. And it's kind of like adding this thing to both sides of the equation. B over 2a. So all I did was I added b over 2a squared to both sides of the equation. So fairly straightforward. And now the factored form of this, you're going to find is x plus b over 2a times x plus b over 2a. And so if you want to, you can use the box to see that. I'm going to just write it out for the sake of space and time. So let's see. The next step will be x plus b over 2a squared equals negative c over a plus b squared over 4a squared. Now, what I did to get this was I just multiplied b over 2a by itself. So you'll notice, like, when you multiply fractions, right, you take the top values and the bottom values and you multiply them together. That's all that happened here. So b times b makes b squared, 2a times 2a. Now, this is a little trickier. 2 times 2 makes 4, and then a times a makes a squared. So it's ended up being 4a squared, if that makes sense. And so now, the next part of it, we'll just basically take the square root of each side here. So, no, that's not the next step. We need to combine this. Well, let's make this easier on ourselves. So we want to add these together. Now, how do we do that? Well, remember when you add fractions, you want to make a common denominator. So that's what I'm going to do. To make this a common denominator, all I have to do is multiply the negative c over a times 4a over 4a. All right, so I'm going to do that, and that'll get us 4ac, or rather negative 4ac over 4a squared plus b squared over 4a squared. So what's remaining when you add these together is b squared minus 4ac over 4a squared, which is pretty cool. It's now starting to resemble something we recognize. So now what we'll do is we'll take the square root. And so what this will get us is x plus b over 2a equals square root of b squared minus 4ac over 2a. Now, why is it 2a? Well, when you take 4a squared, or rather when you take the square root of 4a squared, that will get you the square root of each of those terms individually. Because notice, when you take, we'll just kind of add this section here, 2a times 2a equals 4a squared. All we did was we went backwards from that. So we just said 4a squared goes back down to 2a times 2a. So that's all we did here. And then this, we obviously can't really simplify like the bottom here. So what's remaining? We just have to subtract b over 2a to the other side of the equation, and then we're pretty much finished. So we'll do that. Minus b over 2a. And that'll do it. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And I just combined the 2a here because we have a common denominator again. So that's all there was to that. Now, the only question you might have that I can think of right now is how on earth do you get plus or minus? Well, that has to do with a property involving square roots. So let's take a look at that real quick. When you have a square root, it basically means you're undoing something squared, right? So we know that 2 times 2 equals 4. And I would say you've generally accepted that the square root of 4 equals 2, which is correct. That is an answer. But there's also another answer to this. It could also be negative 2. Because remember, when you multiply a negative times a negative, you get a positive. And so when you do negative 2 times negative 2, you're going to get 4. So really, when you do the square root of 4, you don't know if it's going to be positive 2 or negative 2. Most of the time in a high school class, you'll default to the positive. But this negative option here is why we have plus or minus, because this square root could be positive or negative. And so that's why this plus or minus here exists. So that is how you derive the quadratic formula. Hopefully it made sense. I tried to make it as simple as possible, especially during the confusing, like completing the square portion of it. So I think in pre-calculus, that's when you actually learn about completing the square. So this is a little advanced for the audience that this video is kind of geared towards, but I think it's kind of cool for those of you who want to see, to actually see it done, because it's not a guarantee that someone else will do it. So yeah, this is the quadratic formula. So there is a formative assessment that you can take. The link is in the description, and at the end of the formative assessment, there is the code you can enter for your virtual visitor badge. So I encourage you to do that. Yeah, otherwise, enjoy the rest of your day, and I hope you learned something about the quadratic formula.